So as we work on this particular video, it is expected that you have the notes in front of you for Unit 4.1 talking about exponential functions. So the first thing that we're going to do in this video is just review the rules of exponents. Basically an exponent, so if you have a to the n, right, this means that you're going to take a times a times a over and over again so that you have n factors of a. In terms of actual numbers, that would be like 4 times 4 times 4 times 4 times 4. An easier way to write that is 4 to the 5th power. So that is basically what an exponent is when n is a whole number, or when it is a positive, when n is a whole number. Now, some other things that can happen. What if n is negative? So if you have a to the negative n, well, an exponent in a negative in the exponent does not make the number negative. What it does is it reciprocates the number. In other words, it flips it over. So 1 over a to the negative n is just 1 over a to the n. Similarly, if you have 1 over a to the negative n, that will equal a to the n. So 2 to the negative 1 is the same thing as 1/2. Or 1 over 3 to the negative 1 would be the same thing as 3. So that is what a negative exponent does. Fractional exponents occur as well, and they are basically roots. So if you had the cube root of a number, that is going to be that number to the 1/3 power. In other words, the nth root of a is the same thing as a to the 1 over n power. So if you had, say, 9 to the 1/2, that's basically asking you for the square root of 9, which is 3. A to the 0 equals 1. So any number to the 0 power is 1. It's just that simple. When we multiply like bases, so you have a to the m times a to the m, that will equal a to the n plus m. In terms of numbers, if you had 3 squared times 3 to the 3rd, so if you have that, then you're going to be the same thing as 3 to the 2 plus 3, which is 3 to the 5th. Now, if you think about that, 3 to the 2nd, that's 9. 3 to the 3rd, that's 27. And 9 times 27, right, is 243. That's a guess. I'm getting my calculator out. So, yeah, 243. If you put 3 to the 5th in your calculator, that's also going to be 243. So when we multiply with like bases, the numbers on the bottom are the same, whether we're using algebra, meaning letters, or we are using arithmetic, which is just numbers. We just add the exponents. Notice we do not multiply the bases. the base remains the same. When we multiply with like bases, we add the exponents together. Addition and subtraction are very similar functions, and when we work with exponents, the addition rule that we just looked at is similar to the division rule. A to the n over a to the m equals a to the n minus m. So when we divide with like bases, we actually subtract the exponents. Interesting fact, if you think about what we did earlier with negative exponents, we could rewrite this as a to the n. Moving that up would be a to the negative m, and then when we multiply like bases, we add the exponents, and that would still be a to the n minus m. The nth root of a to the n. This just uses two of our earlier rules together, meaning remember that the index of your radical is the denominator of your exponent. We said that the nth root of a is a to the 1 over n. So just because we have another power inside does not change the way that we work with that. This m is just moved into the denominator, and this is the same thing as a to the n over m. Our last rule is the distributive rule, and exponents distribute over multiplication in much the same way that multiplication distributes over addition. What I mean by that is this: if you had 3 times x plus y, you would distribute that 3 and it would give you 3x plus 3y. Well, exponential distribution works the same kind of way, only instead of adding, we multiply. So we have a times b to the nth power. That n will distribute over those two things that are being multiplied together. So this ends up being a to the n times b to the n. It also works when we divide. So if we were to have a divided by b to the nth power, that would equal a to the n divided by b to the n. So exponents distribute over both multiplication and division.